Okay, next we come to really talking about Binomial Theorem. But beforehand, so let's introduce a very special triangle called Pascal Triangle, which is also used to do expansion in a very quick way. And then the construction of Pascal Triangle, it may be easy, it may be hard for you, but anyway, let's try. First of all, there's one on top, and then 1 continuously. So it goes to like a birthday cake afterward by having 1 at first, 1 at last. Well, the numbers in between will be, so you add up the two numbers on top, so that's why it's 2. And then coming up next, you have 1 at the end and first, and 2 plus 1, you get 3 1 again, 1 3 3 3 3 1, do the addition, so you have 1 4 6 4 1, and then 1 next continue 1 4 4 6 6 4 4 1, 5 1 5 10 10 5 1, and then continuously, maybe this is the last one I try for you, 1 5 5 10 10 10 10 5 5 1, 6 15 20 15 and 6. So this is called Pascal Triangle. And then so what does it use for before we come to really talking about the Binomial Theorem? Indeed, Pascal Triangle is helping you to tell you about the coefficients of the expansion. What I mean, and let's take the easiest one as example. Everyone knows that identity a plus b squared for a while, that consists of a squared, ab, and b squared. But what's the coefficient of each variables? So you will see is 1a squared, 2ab, and 1b squared. This is the identity you've got in the junior form. 1 you can consider it like a plus b to the power 1. So of course everyone knows that it's 1a and also 1b. And then the first layer, you can consider it like a plus b to the power 0, which gives you a 1, because there's nothing except the constant. But of course in this case we need to assume that a, b are not both 0, definitely. And now we come to see how we treat 1 3 3 1 in order to talk about cube. The ways to do will be, okay, let's try together. There are, you can say, 3 procedures. First of all, write a in a descending order of the power 3, power 2, power 1, and 0. Next, you write power b in ascending order of power, no power and no b, b to the power 1, b squared, and b cubed. And finally, you fill in the blanks by the coefficients 1 3 3 1. So there should be 1a cubed, 3a squared b, 3ab squared, and 1b cubed. And finally, you rub away the constant. 1, power 1 remove, 1 remove. So that's why it is the expansion about a plus b to the power cube. You may try one more out like 1 4 4 1. Then it should be a to the power 4, a cubed, a squared, a, and no a. Next, no b, b power 1, b squared, b cubed, and b to the power 4. At last, you fill in the coefficients 1a to the power 4, 4a cubed b, and then 6, 4, and 1. So this is the expansion. Is it easy to you? Hopefully yes. And then in case of negative, so what shall we do? More or less the same, but if you consider like a minus b to the power 3, you can treat it like a plus minus b to the power 3. In this case, you have a cubed, a squared, a, and no a, no b, minus b squared, and minus b cubed. And then fill in 1 3 3 1, 1 3 3 and 1, and you do the simplification of minus b to the power of a number. That is. So example 5, maybe I start the first line for you, and you try to complete the answers. First of all, so there is an instruction called ascending. You need to write your answer in ascending order powers of x as far as the fourth term. So what does that mean? That means you write in this way. So you need 1, 5, 10, 5, 1 first, but you need to make your choice carefully, because like if you write 2x to the power 5 and then 2x to the power 4, 2x to the power 3, 2x squared, 2x and no x, then you have no 3, 3, 3 squared, 3 cubed, 3 to the power 4 and 3 to the power 5. You write in this way, there is not ascending order ascending power of x. So that's why, though it can give you the answer, but you are not using a very smart way to do so. So in this case, I will change the order. I first write 3 to the power 5 first, because the a and b you can make a choice of yourselves. So I write 3 to the power 5, 3 to the power 4, 3 cubed, 3 squared, 3, and no 3. Coming up next is no 2 to the power x, 2x, 2x squared, 2x cubed, 2x to the power 4, and 2x to the power 5. And finally, you fill in the 1, 1, 5, 10, okay, 10, 10, 5, and 1. And you do the work on the details by yourselves. The meaning of as far as the fourth term will be, finally, your answer only consists of 1, 2, 3, 4 terms. And then dot dot plus dot dot plus dot dot plus dot dot and plus dot dot dot, because some terms are omitted as required by the question. So when you say as far as fourth term, then the rest of the term can be neglected, omitted, and you use dot 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 to replace them. Next, we really come to binomial theorem, and also which is a formula in this very terrible expression. Wow, so what was the difference between Pascal Triangle and also binomial theorem? Somehow I would say Pascal Triangle helps you to do expansion in a smaller power like power 4, power 5, because you can write the numbers quite clearly in the Pascal Triangle. But just in case, like when you have power 10, power 7 in example 6 and 7, then you've got lots of troubles if writing Pascal Triangle, because it takes time. So as well as binomial theorem want to generalize the result, I don't want to particularly talking about power 4, power 5, power 7, power 10, etc. But I want to write down, what if it's power n? Can I have a general formula to write it? So that's why that's what binomial theorem is telling you. And then next, but the principle. Now we come to take a look on how the formula is written, and then so it helps you to understand it afterward. Once again, if you expand x plus y to the power n, the general idea is more or less the same. You first write x from power n minus 1, power n minus 2, until okay, plus until power 2, power 1, and no power. Conversely, you write power of y from 0 to power n. So that's why you have no y, y squared plus until is y to the power n minus 2, y to the power n minus 1, and also y to the power n. So now the coefficients will be the core problem of binomial theorem, because you can't retrieve the numbers from from Pascal Triangle. And the NCR itself, now it provides you the answer, because if you expand the things in binomial theorem, all the coefficients will be related to NCR. So for details, you may try to read your book, or maybe you search into Google, and it helps you tell you the reason behind it. And so how we write it should be NC0, NC1, NC2, NCn minus 2, and then NCn minus 1, and NCn. So this is called Binomial Theorem. In short, we will use summation sign to have an abbreviation. But generally speaking, you see my 3 steps on writing binomial expansion, which is x from largest power to 0, y from power 0 to largest power n, and then you fill in NC0, NC1, NC2, etc. And the next a remark I would like to mention here would be, do you remember that we proved identity before called NCR is equal to NCn minus R? So indeed, it's telling you that NCR itself is like symmetric. So what do I mean? That means besides using NC0, NC1, NC2 up to NCn, you can write in reverse order. That means if you don't write NC0, you can start from NCn, NCn minus 1, NCn minus 2, NC2, NC1, and NC0. So it also gives you the same result. So occasionally, in some question, we start from NC0. In some occasions, we start from NCn. So later on, when you try your exercise, you may experience more afterward. And now let's try to take a look in example 6. So I start the first line for you. Is ascending power of x as far as the fifth term. Talking about power 10, that means n is 10 over there. So because it's ascending power of x, so that's why I start from 4 to the power 10, 4 to the power 9, 4 to the power 8, 4 to the power 7, 4 to the power 6, and plus a dot, because a number of terms they are missing. I need to leave some space. Okay, afterward it will be no x, x over 2, x over 2 square, x over 2 cube, and x over 2, 2 to the power 4. Then you fill in the blanks. In this case, you will see that now the power of x are in ascending order from no, power 1, power 2, power 3, and power 4. And last, we fill in the blanks. N is now 10, so it should be 10C0, 10C1, 10C2, 10C3, and 10C4. Then by calculator, you can get these numbers, simplify with 4 to the power 10, and you have to obtain the answer in the format of several terms add up and plus dot 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 afterward. In the coming example, it's a bit special because there are 2 binomial expansion over there. So we need to treat them separately in the expansion in order to find the answer. And then now we take a look on the keywords of the question. Again, the question is asking you to write in ascending order until the term x squared. And then next, the other part will be asking you about constant term, which is 27. Constant term here, if you still remember, it means that it's a term without xc. And then so that's why, according to this given information, you're going to find the value of p. And now we come to take a look in part B first, of course. And now, because the power is quite small, power 3 and power 4, so that's why I would suggest to use Pascal Triangle instead of NCR to solve it. And then so going back to the Pascal Triangle, the layers should be 1, 3, 3, 1, and power 4 should be 1, 4, 6, 4, 1. And next, let's take a look. For p plus 3 x cubed, and how about I consider both of them together as follow, but each bracket will be considered separately. And according to it, we have p cubed, 3p squared with x, 3 again, but p to the power 1 this time, x squared, and at last x cubed. So if you can't figure out p cubed, p squared, x, px squared, x cubed here, so please go back to the previous examples to help to revise the concept. While power 4, because of the mass 5x, I think I would be slow down. So first of all, you have 1 to the power 4. So I prefer to write 1. Next, you have the number 4 as a coefficient. 1 to the power 4, maybe this time I'll write for you. And then minus 5x. You have 6. 1 to the power 3, minus 5x squared. You have 4, 1 squared, minus 5x to the power 3. And finally, minus 5x to the power 4. And then so this is the full expansions of the two binomial or in two brackets. Coming up next, we need to simplify it because I need to expand the brackets as well. So I rewrite the things as follow. Okay, next, so you have 4 and minus 5, so which is minus 20. And then next you have 6 and minus 5 square, so which gives you minus 150x squared. And then now I will be putting focus on the word called as far as the term in x squared. That means we won't consider power 3 and power 4 afterward. So I'm a bit lazy to write dot 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 here. Okay, afterward, then we continue to expand the brackets so that it will be writing term by term from constant term, power x to the power 1x squared, and so and so. Now let's expand p cube first. P cube and 1 is p cube. P cubes and minus 20x is minus 20 p cube x. P cube and minus 150x squared is minus 150 p cube x squared. That is. Next I have 3px squared. 3p squared x times 1. You have 3p squared x here. 3p squared x again. Then you have minus 60p squared x squared. I won't multiply the third one because it goes to x to the power 3. It's too big as in our consideration. So that's why again I'm lazy and not to write it. In this situation or in this consideration, 3p x squared will be multiplied to 1 only, which gives you 3p x squared. And then finally, don't forget to write dot 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 because you ignore a number of terms over there. And finally, we now need to group the terms together. P cube is the only constant term right there. Then you have two terms involving x. I put them together. Minus 20p cube, 3p squared, x. And the last three terms, they are involving x squared. So I have minus 150 p cube, minus 60 p squared, and 3p x squared, and that is. And it finishes part A. Part B will be, it tells you about constant term is 27. That means p cube is 27. By calculator, then you've got p is 3. So that's all. Sometimes in the exercise or examination, we may be asking you a question like coefficients of x. And so after you've got p is 3, so that's why we have minus 20, 3 cube, and then 3 and 3 squared, which gives you minus 503x. And there will be a follow-up question. Wait, let's hold on. I make a mistake, and can you help to find it? Yes, when you talk about coefficient, we shouldn't include the x here. So it's just merely about the numbers, constant numbers, and minus 113 only. So that's why when you are asking about the word called coefficient, please be careful, we don't include the x in our answer. Next example is a very important one, or a very representing one, which you can find in the HKDSE, because so you can notify it is about part n in the question. So that's why we need a special technique which will be introduced in the coming explanation. And now it tells you that and you expand it, you have 1, 6x, 16x squared, and it also tells you that there are some terms involving higher power of x is omitted. So that's why That's why when you do the question, it means you need to expand the brackets by yourselves. And now you're asked to find a and n because you've got two important information. Actually, it's 3, 1, 6, and 16x squared respectively. So now maybe you don't have any idea of doing the question, but the main point will be this is the only expression we have. We know this about 1, 6x, and 16x squared, which means we're going to expand it. So by binomial theorem, you should have NC0. And this time, because it's in ascending power of x, I choose the 1 first, which is power n. Next term is NC1, 1 to the power, okay, write down the power, n minus 1, yes. And you have AXE. NC2, 1 to the power, correct, n minus 2. And you have AX. Remember that you have brackets square as well. Dot dot dot, that means those are the terms we're not going to, or we need not to consider. Now we come to the most important thing I would like to say is something about the technique, because now you've got 3 terrible terms there. Terrible not because of the symbol, it's because there's an unknown n which you cannot use calculator to find it. So of course you can. So we need to go back to definition, which NCR is n factorial, n minus r factorial, and r factorial. By this formula, you can find NC0, NC1, NC2 respectively. But the little technique or the trick is, because these 3 numbers are very well known or very common to us, so that's why I suggest you to remember the following, which is NC0 is a 1, but repeat, is done or is found by definition. Please, you may try it yourselves. NC1 will be n, NC2 will be n minus 1 over 2. So please remember these 3 values which will be very useful in your coming work. If you want to have some more, indeed, so what should I say? When you have NC3, the principle is on top is 3 terms, n minus 1, n minus 2. At the bottom is 3 numbers from 1, so you have 1, 2, 3, that means divided by 6. So similarly, you can have NC4, 4th term on top, n minus 1, n minus 2, sorry, no space, n minus 3, divided by 1, 2, 3, 4 at the bottom. By the way, let's go back to the question itself. NC0 is 1, 1 to the power n is 1, so that's why it's 1. It matches with the given information. Then you have n, 1 to the power n minus 1 is 1, so you have NAXE. NC2 is n minus 1 over 2, 1 to the power n minus 2 is 1. AX bracket square, that means you have a square, x square, dot dot dot. Now you go back to the concept of comparing coefficients. You have NA, so which is a 6. You have n minus 1 over 2 a square, which is a 16. So in these circumstances, that means you have now 2 expressions. Things about XC will be equal to 6. Things about what? About x squared will be 16. So is it clear enough to you? Yeah, probably, because you're going to solve the equations by yourself. But unluckily, you can't use calculator simply because it's not like a plus b, a minus b this time, but you have a product. So that's why in this expression, we will rewrite it as you have 2 choices. You either call n is 6 over a, or a is, 6 over n. But when you read equation 2, there are 2 n here, so it's not wise to choose the first choice. So that's why I will pick the second one in order to substitution of a squared. In M2, you can make it fast by not writing from 1 and then change it to 3, so and so. And I just rewrite it as n minus 1 times what? 6 over n divided by 2, you're 16. And then at last, check whether you've got the result. A is 9. And so as a result, A will be 6 over 9, which is 2 over 3. So the question itself will be reminding you or telling you that when you have a question about power n, so you have a special technique. The technique actually is like a dictation. So make sure that you can remember NC0, NC1, NC2 clearly. So if you want to be more ambitious, you want to know more, then you also remember the way how we get NC3 as well.